Let's take a look. So here we've got a problem. Hong and Jessica left the airport at the same time. All right. Hong and Jessica left the airport at the same time. They drove in opposite directions. All right, so this is again is another problem where you've got a certain distance traveled this way, you've got a certain distance traveled that way, and then you've got another distance traveled that way. All right. So you got Hong and Jessica left the airport. This is the airport, by the way. That's the airport. All right, so Hong and Jessica left the airport at the same time. They drove in opposite directions. Let's call this Jessica. Let's call this Hong. All right. Jessica drove 20 kilometers per hour faster than Hong. Jessica drove 20 kilometers per hour faster than Hong. After 1 hour, they were 100 kilometers apart. Find Hong's speed. All right, so again, I've mentioned this a couple times already. These are distance is equal to rate times time problems for both individuals. Distance equal to rate times time. Now, notice how this says that Jessica drove 20 kilometers faster. All right, so the way we're going to handle that is if you got Hong's speed, see, let me talk to you a little bit. This problem said that Jessica's driving 20 kilometers an hour faster than Hong. Jessica's driving faster than Hong. They don't tell you how fast the individuals are traveling. So it could be Hong is driving 10, Jessica's driving 30 kilometers per hour. It could be that Hong is driving 20, Jessica's driving 40. You don't know the rates at which they're traveling. The only thing that you know is whatever speed Hong is driving at, Jessica is driving 20 kilometers per hour faster than that. All right, so it's important that you really understand the problem. That said, let's show you how we're gonna present that mathematically. Let's show you how we're gonna present that mathematically. All right, so you don't know Hong. You don't know how fast Hong is driving. The only thing you know is that Jessica's speed is going to be 20 more than Hong. That's how you're going to write that mathematically. They don't give you rates, so you use variables. Hong's rate is unknown. Jessica's rate is unknown. The only thing that you know is she's 20 kilometers per hour faster than Hong. It's very important you know how to write that mathematically. All right, now those are the rates. Kilometers per hour, those are rates. So let's substitute that. The rate for Hong, let's just call that H. That's our rate there. And the rate for Jessica, that's H plus 20. Those are rates. Distance is equal to rate, and I substituted rates each time. All right. It says they drove in opposite direction. Jessica drove 20 kilometers per hour faster than Hong. After 1 hour, that's key there, that's a time. After 1 hour, they were 100 kilometers apart. So they gave you the time. They were each traveling 1 hour. It appears as though, they left from the airport at the same time. So they each drove a time of 1 hour. All right. Yeah, see, they left at the same time. So after 1 hour, they both travel an hour. All right. So now this distance for Jessica is here, and the distance for Hong is here. All right. So it says after 1 hour, they were 100 kilometers apart. So what I'd like to do here is show you that this distance from here to here, that had to be 100 kilometers. That distance there is 100 kilometers. All right. So now you're taking this distance that Jessica traveled, this distance that Hong traveled, and you're going to set those equal to 100 because that's a total distance after 1 hour. So we have H plus 20 h 1 times h plus 20 is h plus 20 plus h. You're adding these two distances together, and those two distances together should equal out to 100. Now this is just a basic algebra problem. You get 2h plus 20 is 100. You subtract the 20. You subtract the 20. You get 2h is 80. And you end up with h is 40. That is Hong. The question says, find Hong's speed. Well, Hong's speed was 40. If the question would have asked, what's Jessica's speed? You would have taken that 40 and added 20 to the 40. Okay? So, as I said to you earlier, they said that Jessica was driving 20 kilometers per hour faster. You didn't know Hong's speed. Hong could have been going 10. Jessica would have been going 30. Hong could have been driving 20. Jessica would have been going 40. But we calculated it out, and we discovered that Hong was driving 40 kilometers per hour. I like these problems because what they do is they require students understand a couple of things. You have to draw a nice diagram. That's somewhat of a skill. You have to be fluent in algebra, being able to solve this algebraic equation. That would be necessary for you. And then you have to understand this idea of distance equal to rate times time. That relationship between distance equal to rate times time. This is why you find these kinds of problems on the different standardized tests. On the ACT, PSAT, these kinds of tests, each problem requires multiple skills. The same problem might require a technique that you learn in algebra. The same problem might not only require an algebraic technique, but you might have to remember something you learned in geometry, algebra 2, trigonometry, and in the context of one problem. So this is why these kinds of problems are common in the different standardized tests.